Welcome back to Bite-Sized Breakthroughs, the podcast where we break down complex research into digestible bites. Today, we're diving into a fascinating paper that explores a new approach to understanding and interacting with mobile user interfaces. Joining me today is Dr. Paige Turner, a leading researcher in the field of multimodal AI, and Professor Wood Spectrum, a renowned expert on human-computer interaction.
Thank you for having me, Alex. It's great to be here. Likewise, Alex. I'm always eager to discuss the latest advancements in UI understanding, a field that's evolving rapidly.
Absolutely, Professor Spectrum. To set the stage, could you give us a brief overview of the current landscape in mobile UI understanding and why it's so important?
Well, Alex, mobile apps have become an indispensable part of our lives, serving as tools for everything from information search to entertainment and communication. But the ability for AI to truly understand and interact with these interfaces is still a major challenge. Earlier research focused on simpler web and mobile screens, but the advent of powerful large language models and multimodal AI has opened up new possibilities for more sophisticated UI comprehension.
So, Dr. Turner, this paper focuses on Ferret-UI, a multimodal, large language model specifically designed for understanding mobile UI screens. Could you tell us more about the paper's main contributions and why it's such a significant step forward?
You're right, Alex. Ferret-UI is a breakthrough in mobile UI understanding. It introduces several key innovations which address the limitations of existing approaches. First, it's the first UI-centric MLLM capable of executing referring, grounding, and reasoning tasks. That means it can identify specific elements on a screen, understand their relationships, and even deduce the screen's overall function. Second, the paper meticulously curates a comprehensive dataset of elementary and advanced UI tasks, providing the model with a broad and nuanced understanding of UI elements and interactions. Lastly, they've developed a comprehensive benchmark to evaluate the model's capabilities and limitations, which is crucial for measuring progress and guiding future research.
That sounds impressive, Dr. Turner. Could you explain those key terms, referring, grounding, and reasoning, in a way that listeners can easily grasp?
Sure, Alex. Think of it like this. Referring is the ability to point to a specific element on the screen, such as an icon or text. Grounding takes that a step further by identifying the exact location of that element. So if I ask Ferret-UI, find the login button, it would not only understand login button, but also be able to pinpoint its exact location on the screen. Finally, reasoning refers to the model's ability to understand relationships and make deductions about the UI. For example, if you ask it, how do I share this article on social media? Ferret-UI might infer that there's a share button on the screen and provide the correct instructions based on its location and function.
That's a great analogy, Dr. Turner. So, how does Ferret-UI actually work, and how does it differ from existing methods for UI understanding?
Ferret-UI builds upon the Ferret architecture, a multimodal large language model known for its strong referring and grounding capabilities in natural images. However, UI screens are quite different from natural images. They often have more elongated aspect ratios and contain smaller objects of interest like icons and text. That's where the any resolution or any res approach comes in. It divides the screen into sub-images based on the aspect ratio, either horizontally for portrait screens or vertically for landscape screens. These sub-images are then encoded separately, providing the model with a more detailed understanding of the visual content. In addition to the global image features, Ferret-UI uses these sub-image features, along with text embeddings, to generate its responses. This allows it to handle the intricate details and smaller elements common in UI screens.
So, essentially, Ferret-UI is breaking down the screen into smaller pieces to get a better look at the details, right?
Exactly, Alex. It's like zooming in on specific areas of interest to get a more accurate understanding of what's happening. This approach distinguishes Ferret-UI from previous works that often treated the entire screen as a single input, limiting their ability to refer to specific elements. It also overcomes the limitations of general domain MLLMs that were primarily focused on natural images and not well suited for UI comprehension.
Professor Spectrum, could you provide some insights into the broader context of Ferret-UI's innovation? What are the potential implications of this research for the field of human-computer interaction?
Ferret-UI's ability to understand and interact with mobile UIs has the potential to revolutionize human-computer interaction. Imagine applications that can assist users with disabilities in navigating complex apps, or AI agents that can seamlessly interact with our phones on our behalf to perform tasks. This research also paves the way for improved app testing and development by automating tasks and identifying potential usability issues. Overall, Ferret-UI represents a major step toward building more intelligent and intuitive user interfaces.
That's a great point, Professor Spectrum. But how do the experimental results support these broader implications? Dr. Turner, could you walk us through the paper's methodology and key findings?
Sure, Alex. To train Ferret-UI, the researchers meticulously curated a dataset that includes a wide range of tasks, from basic ones like icon recognition and OCR to more advanced tasks like detailed description and conversation interaction. They used GPT-4, a powerful language model, to generate data for these advanced tasks. The dataset covers both iPhone and Android screens, making it quite comprehensive.
And how did they evaluate Ferret-UI's performance?
They used a comprehensive benchmark that included various elementary and advanced UI tasks, comparing Ferret-UI against several other models, including open-source UI MLLMs like CogAgent and Fuyu and GPT-4v. The results were quite striking. Ferret-UI significantly outperformed all other models on elementary UI tasks, including icon recognition, OCR, and widget listing. It also surpassed other models on advanced tasks, showing remarkable abilities in detailed description, conversation interaction, and function inference.
That's a lot of data to unpack. Can you share some specific numbers or statistics that highlight Ferret-UI's achievements?
Of course, Alex. For example, on the task of widget captions, where the model needs to provide a short description for a specific UI element, Ferret-UI achieved a CIDR score of 142, which significantly surpasses the score of 141.8 achieved by Spotlight, a model trained on a much larger dataset. On the tape perception task, where the model needs to predict whether a UI element is tappable, Ferret-UI achieved an F1 score of 78.4, which is comparable to the performance of Spotlight. And in the advanced task of conversation interaction, where the model needs to generate responses that include specific actions and reference UI elements, Ferret-UI achieved a score of 93.9, outperforming other models like Fuyu and CogAgent.
Those are impressive numbers, Dr. Turner. It seems like Ferret-UI is truly pushing the boundaries of UI understanding. But what about the model's limitations? Is there anything it struggles with?
That's a great question, Alex. One major limitation is Ferret-UI's reliance on the underlying UI detection model. If the detection model misses certain elements or makes errors, Ferret-UI won't be able to learn or interact with those elements. For example, Ferret-UI cannot learn about aspects like colors, design, usability, or UI elements that the detection model misses, such as the time, battery, or Wi-Fi indicators. Also, the set of mark prompting approach used for evaluating GPT-4v has limitations, particularly when dealing with small UI elements. This restricts the model's ability to refer to those elements freely. Furthermore, the current model primarily focuses on tap interactions. Future research should explore interactions involving other actions, such as scrolling, long-clicking, and entering text.
Professor Spectrum, what are your thoughts on these limitations and their implications for future research?
It's important to recognize that Ferret-UI represents a significant step forward, but it's not the final word on UI understanding. Addressing these limitations is crucial for the model's future development and broader impact. Future research should focus on improving the UI detection model's accuracy, exploring alternative prompting methods that allow for more flexible interactions, and expanding the model's capabilities to include other types of UI interactions. We also need to consider the ethical implications of such powerful AI systems, ensuring their development and use align with human values and promote inclusivity.
It sounds like Ferret-UI is just the beginning of a much larger journey, Dr. Turner. What are your thoughts on the potential applications of this research and its broader impact on the field of AI?
Absolutely, Alex. The success of Ferret-UI has significant implications for various fields. It could revolutionize accessibility for users with disabilities, enabling them to interact with mobile apps more easily. For app developers, Ferret-UI could automate testing and identify usability issues, leading to better user experiences. And in the field of AI agents, the model's capabilities could be harnessed to develop more sophisticated agents that can interact with mobile devices autonomously, performing tasks and retrieving information. Overall, Ferret-UI represents a significant step toward creating AI systems that can better understand and interact with our digital world.
Thank you, Dr. Turner and Professor Spectrum, for this insightful and comprehensive discussion of Ferret-UI. It's clear that this research has the potential to reshape how we interact with mobile technology. By combining sophisticated AI techniques with meticulous data curation and a focus on UI-specific tasks, Ferret-UI is setting a new standard for understanding and interacting with mobile UIs. It will be exciting to see how this research continues to evolve and impact various fields in the future.